Question 10 says, with increasing biasing voltage of a photodiode, the photocurrent magnitude, well, there are different options. And how does the photocurrent magnitude change with increasing the biasing voltage? Clearly, the question is from the topic semiconductors, and it's about the optoelectronic devices. Okay, here we are talking about the photodiode, and the question is based on facts. It's a factual question. If we look at the graph of current versus the voltage that is applied, the graph goes something like this. On this side is current and on this side is voltage. The graph is something like this. Clearly, initially the current increases and then it achieves a saturation value. So, that means clearly option 3 is the correct option for question 10. Let us now go to question 11. Question 11 says, a physical quantity Z depends on 4 observables A, B, C and D as, well, this is the expression for Z. In fact, the percentage error in the measurement of A, B, C and D are given. We have to find the percentage error in Z. Clearly, the topic is units and measurement, and it is about error, in fact the propagation of error. Well, we can see that the errors are not very large, so we can apply the formula that relative error in Z is given as, in this particular case, relative error in Z, delta Z by Z is 2 times of delta A by A. So, 2 times of delta A by A plus 2 by 3 times of delta B by B, and then plus 1 by 2 times of delta C by C. So, this is 1 by 2 times of delta C by C, and finally 3 times of delta D by D. So, let us put it here, plus 3 times of delta D by D. All the errors are given. If we add up all the percentage errors, this comes out as 14.5%. For question 11, option 2 is the correct option. Let us now go to question number 12. Question 12 says, 3 different processes that can occur in an ideal monoatomic gas are shown in the P versus V diagram. The paths are labeled as AB, AC and AD. The change in internal energies during these processes are taken as EAB, EAC and EAD, and the work done as, well, WAB, WAC and WAD. Which is the correct relation between these parameters? That is what we are to find. And if we look at the options, these are the options. Well, one thing is for sure, we are going from one isotherm to the other isotherm, and that means change in temperature is same in all the 3 cases. So, the gas sample being the same and the change in temperature being the same, clearly the change in internal energy is going to be the same for all the 3 processes. So, that means EAB must equal EAC must equal EAD, and which brings us straight to option number 2, because all other options are not matching with this. Okay. So, if we look at option 2, so this part is done, this is absolutely correct. WAB is positive. Actually, it indeed will be so, because, well, the volume is increasing. So, the work done by the gas would be positive. So, WAB is positive. WAC, we can see that AC is an isochoric process. So, WAC is 0, is also correct. What about WAD? Well, from the graph it clearly shows that, D is to the left of point A, and that means in the process AD the volume is decreasing, and in that case the work done is going to be negative. So, that means this is not correct. Okay? It does not really match, and if it does not match, others clearly do not match anyway, because they violate the condition that EAB equals EAC equals EAD. So, for this particular question, it seems there has been a mistake. None of the options match. Well, I hope the discussion is clear. Let us now go to question number 13.